Welcome back, men, from spring break. I hope everyone had a nice, relaxing time and that everyone is healthy and that you got to just enjoy being here in town. We're going to carry on today to section 6.6, and that is trapezoids and kites. This is our last section of this chapter. So a trapezoid is a quadrilateral with exactly one pair of sides parallel. So over here, I have a picture of a trapezoid, and these are the two parallel sides. The parallel sides are what we call the base. The non-parallel sides are what we call the legs. The angles are what we call the base angles. They're called the base angles. So in this trapezoid, we have four base angles. Pardon me. We have four base angles. So the base angles. There are four of them. I have some right here in the north, and I've got some down here in the south. If the legs are congruent, like the picture to the right, so here these legs are congruent, this is called an isosceles trapezoid. And we're going to learn some theorems about these isosceles trapezoids. Theorem 6.21 says if a trapezoid is isosceles, then each pair of base angles is congruent. So if I have an isosceles trapezoid, the base angles are congruent. If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. And then theorem 6.23, a trapezoid is isosceles if and only if its diagonals are congruent. So an isosceles trapezoid will have congruent diagonals. So each side of the basket shown is an isosceles trapezoid. If the measure of angle JML is 130 degrees, so I'm just going to highlight that angle, J to M to L. That's this angle right there. That angle is 130 degrees. And it says that KN is 6.7 feet and MN is 3.6 feet. Find the measure of MJK. Well, when I look at this, I know that this line, JK segment, and this line segment, ML, are parallel. And because they are parallel, I have a transversal, which is segment JM. So that means that the measure of angle MJK plus the measure of angle JML has to equal 180 degrees. They are same side interior or consecutive interior angles. This angle right here, JML, was 130. So that means that the measure of angle MJK is equal to 50 degrees. And I'm done. It says each side of the basket is an isosceles trapezoid if JML is equal to 130 and KN is equal to 6.7 and MN is 3.6. We need to find the length of diagonal JL. Well, because this is isosceles, we know that the length of segment JL is equal to the length of segment MK. So JL equals MK. MK is equal to 6.7 plus 3.6. So if I do that, that should be 10.3 feet. So JL equals 10.3 feet. Moving on to my next example, it says, what are the measures of the angle D, E, and F? I know that this is a trapezoid, so DEFC is a trapezoid, and it is isosceles. So here, angle C is 65 degrees. That means that angle F is a base angle with 65, and they are congruent. So angle F is 65 degrees. And that means that the measure of angle D right here is going to be 180 minus the 65. So 180 minus the 65, that is 115 degrees. And since that's 115, I know because it's isosceles that angle E also has to be 115 degrees. I'm finished. If we look over here, this is angle P right here. It got cut off, so pardon me there. So we got P, Q, R, and S. We know that angle R is 106, so that means angle S is 106. They are the base angles. That means angle Q will be equal to 180 minus 106. That's 74 degrees. So angle Q is 74 degrees and angle P is 74 degrees. We are finished. A mid-segment of a trapezoid is parallel to each base, and its measure is half the sum of the lengths of the bases. So here, if I wanted to know what is the length of segment BE, it is half of the length of segment AF plus the length of segment CD. And you might be asking, what is a mid-segment? So we'll just put this over here. A mid-segment is a segment that connects the midpoint of two sides of a trapezoid. So here's our theorem in short. It says if a quadrilateral is a trapezoid, then the midsegment is parallel to the bases. And the length of the midsegment is half the sum or the average of the lengths of its bases. So here in the figure, MN is the midsegment of my trapezoid FGJK. What is the value of X? So I know that MN is going to be equal to 1/2 of the length of segment KF plus JG. So in this problem, I know that 30 is equal to 1/2 of KF, which is 20, plus JG, which in this problem is X. So, in order to get rid of this fraction, I'm just going to multiply both sides by 2. If I see I have a denominator of 2, I multiply both sides by 2, and that will give me 1. So all I'm left here is what is right here in these braces, the brackets. So 30 times 2, that is 60. So 60 equals 20 plus X. Remember, what is going on right here, the 2 times 1/2, that becomes 1. So 1 times this quantity is just 20 plus X. Now all you do is subtract the 20, and you get that 40 is X. Alright, so I have that WXYZ is isosceles trapezoid. That should be with midsegment JK. So I need to find the length of XY if JK is 18 and WZ is 25. So I'm going to write out my formula. I know JK is the midsegment. JK is equal to half, and that is XY plus WZ. Well, JK in this problem is 18. That is 1/2. XY is unknown, so I'm going to keep that XY plus WZ, which is 25. So in order to solve this, you multiply both sides by 2. 18 times 2 is 36. 36 is equal to XY plus 25. I subtract the 25, and I get that 11 is the length of segment XY. All right, 2 more theorems here for us. These are all about a kite, and it says if a quadrilateral is a kite, then its diagonals are perpendicular. So a kite is a quadrilateral with 2 pair of consecutive sides congruent. It's a quadrilateral with 2 pair of consecutive sides congruent. So when I look right here, I see that I have a pair of consecutive sides and then the second pair. So I get this kite, and it says that the diagonals are perpendicular. So if you were to go and fly a kite and we put that kite together, these segments right there on the interior, some people call those the ribs, and we know that the ribs form a right angle. It looks like a cross. 6.26, if a quadrilateral is a kite, then exactly 1 pair of opposite sides is congruent. So here we got exactly 1 pair of opposite, not sides, pardon me, but angles are congruent. So here angle J is congruent to angle L. So let's take a look at our example. It says if WXYZ is a kite, find the measure of angle XYZ. So I want to find that angle right here. I know that this is a kite, so that angle Z is going to be 121 degrees. And because it's a quadrilateral, all of these angles have to add up to 360. So we're going to do 2 times 121 plus 73 plus the measure of angle XYZ equals 360. 242 plus 73 plus the measure of angle XYZ equals 360. 242 plus 73, that's 315, plus the measure of angle XYZ is 360. So that means the measure of angle XYZ is equal to 45 degrees. I gotta subtract that 315 from both sides. Here, angle 1 is going to be, and the kite DEFG, angle 1 is 90 degrees because that's the intersection of the diagonals. 90 minus 52, that's going to be 48. So angle 2 is 48 degrees. And then angle 3, if we look, we got congruent triangles. So the measure of angle 3 is going to be 52 degrees. All right, angle 1 in this next example, again, angle 1 right here is going to be 90 degrees. Why is angle 1 90 degrees? Right here, these are the intersections of the diagonals. So what is the measure of angle 2? 90 minus 36. That's going to be angle 2. So that's going to be 54 degrees. And then angle 3 is 36. It's congruent triangles. So we just did that example. Some of you guys may recall the Pythagorean theorem. We know that that angle right here in the middle, angle NRM, is 90. I could find MN because I know that MN is equal to NP. So these are the legs. Remember, leg, MN is my hypotenuse. So we said that it was leg squared plus leg squared equals my hypotenuse squared. Okay, so leg squared plus leg squared is hypotenuse squared. 6 squared plus 8 squared is mn squared. That's 36 plus 64, that is mn squared. 36 and 64 is 100, that is equal to mn squared. We take the square root of both sides because that quantity is being squared, so that undoes the squaring. Square root of 100 is 10. So mn is 10, and since mn is 10, that means that is equal to np. I could do the same thing over here to find KL. Again, JK equals KL, or LK. So 3 squared plus 4 squared equals JK squared. That's 9 plus 16 is JK squared. 25 equals JK squared. If I take the square root of both sides, I get 5 is equal to JK. And since JK is 5, that means LK is also 5, or KL is 5. So what I have here is our hierarchy chart. We're going to complete it. What did we study? We studied quadrilaterals. And then we studied a specific type of quadrilateral where they have one pair of parallel sides, and that's what we called a trapezoid. We studied a specific trapezoid today that was the isosceles trapezoid. Then we looked where we had no pair of parallel sides, and that was a kite. And then we studied quadrilaterals that have two pair of parallel sides. And we said right before the break, that was a parallelogram. The specific parallelogram that we looked at was a rectangle, and then we looked at a rhombus. And a rectangle and rhombus, if we have both those properties, it's a parallelogram that has properties of a rectangle, and a rhombus that was a square. So remember, I said we could work our way up the hierarchy chart, meaning that all squares are rectangles, all squares are rhombus, but not all rectangles are squares. Some rectangles are squares, some rhombus are squares. So you can work your way up the hierarchy chart, you cannot work your way down. So an isosceles trapezoid is a quadrilateral. A kite is a quadrilateral, but not all quadrilaterals are isosceles trapezoids. I hope you found today's lesson to be helpful. Please check Schoology for your assignment. Have a great day.